and demonstrate how you can run these models locally on your own computer without internet access and no need to send any data to the cloud or to servers hosted in China or anywhere else in the world. So the easiest way to do something like this is to use a little program called Ollama. Now this is just a framework for running large language models, AI models. Many of them are quite popular, and some of them you've probably heard of. Ollama is not an AI model itself. It's just a framework for running the models on your own computer. It doesn't have anything to do with a specific model like DeepSeek. So let's download the app. It's very small. And let's go ahead and just drag it into the applications folder. And in your applications folder, you can go ahead and start it up. It's going to put a little icon up here in your menu bar. And this application doesn't really have a user interface. The little icon just shows that it's running in the background, but it's really a type of server that runs on your own computer. And you access it from the command line using terminal. Now, what can you do with it? Well, you can download and run a variety of different AI models. We will start with a small one, which is Phi4. This is made by a research team at Microsoft. It's pretty small, 14 billion parameters, and it's very, very fast and quite capable. So you can browse the models here on Ollama.com, and most of these are free to use for almost any purpose. But if you click on one of them, you get some more information. Here's Microsoft demonstrating on a chart how it compares performance-wise to other larger models and what sort of things it's good at. But over here on the right is the command that you need to use to basically download and run the model. So we're going to copy that command, and then we're going to go to terminal. And all we need to do is paste that command in. And it's going to connect to whatever servers are hosting the parameter files for the model, and it's going to download those. Now, if you don't have a fast internet connection, this could take a while. Most of these models are measured in gigabytes. So this one is 9.1 gigabytes, so keep that in mind in terms of download time. Some of the larger models are measured in tens or even hundreds of gigabytes. So let's give this a few moments to download. Once the model has been downloaded to your own computer, you don't need internet access anymore to run the model or use it. So that's what I mean when I say you can use the model offline. The parameter files are basically the weights for the model. It's a whole database of numbers that function as numeric weights in a neural net. So this basically controls the calculations that are performed. When you type in a prompt, the neural net does billions or trillions of calculations, and those calculations are controlled by these weights. And it determines which pathways in the neural net get activated, and then that is what creates the generated output that you receive from your prompt. And all of that can happen on your own computer. No need to go to any website or use any AI app or ChatGPT or anything like that. So here it is. I'm just going to minimize this, and the model has downloaded and has started running. And Ollama, when you run a model like this from the command line, it puts you into a little chat session so that you can interact with it. So we're going to ask it to tell us about itself. And as you can see, this is quite performant. It's providing output faster than I can read it. So for a single user, this is more than adequate. And then we're back to where we can enter another prompt. But I'm going to go ahead and exit Ollama, the chat session. It's done by /by. And I'm just going to demonstrate here that this will work perfectly well offline. So first I'm going to just ping Google to show you that I'm on the internet. Okay. And then I'm going to turn off my Wi-Fi and go back here and we'll ping Google again. And as you can see, it's no longer reachable. I'll ping a Google DNS server, same thing. So we're definitely not online anymore. But if I run this model again, because it's already been downloaded to my laptop, the files are already there, it starts up right away. Okay, and of course these chat sessions are ephemeral. Nothing that you type in stays in the computer's memory or is written to the hard drive or anything like that. When you exit the chat session, it all disappears. It's just temporary. Kind of like ChatGPT, if you tell it not to remember anything and you use it without signing in. Let's see if this model is any good at writing code. Let's say, can you write me a small Python program that will create a list of 10 random numbers, sort them using an explicit bubble sort algorithm, and then display the original numbers along with, or say followed by, okay, so we're asking it to write some code. And here's the code that it's given to us. Now, for some reason, the Ollama chat in the terminal puts these little 3 dots at the beginning of continued lines when you're typing in your prompt. And that can be kind of annoying if you go back to cut and paste, so just keep in mind. But here's a little Python program. It looks good to me. Let me just copy this code here. And I'm going to exit my chat session. And using the little nano text editor, I'm going to paste in this program and try running it. Now I have Python 3 installed. There's the program. So here's the random numbers, 83, 97, 55, so on. And here's the sorted output, 3, 36, 38, 43, 44, 51, 55, 83, 97, 98. So it looks like the code is good. I mean, I didn't really go through it with a fine-tooth comb, but it's probably not a mission-critical application either. All right, so let's get back on the internet and take a look at running a much larger model like DeepSeek, which everybody's talking about. So what makes DeepSeek so special? It's very, very high performance for its size, and it's a reasoning model. So it can do things kind of like the ChatGPT O1 model. It explains its thinking process, so it's good for much more in-depth problem-solving tasks. I wouldn't recommend it for chat so much because it's going to be slower, and most of us aren't interested in reading the thinking process when we're just doing a chat. But here's what we have. They do have the model, and there's some information about it, and some performance metrics, and the license. And this is an open source model with open weights. You can do anything you want with it, pretty much. MIT license generally requires that you give the original developers some kind of written credit in your documentation if you use it in a commercial product. But other than that, there's generally no restrictions. You can't claim that you invented it yourself, but you can certainly use it for free. Let's talk a little bit about the different sizes that are available. We've got models 1.5 all the way up to 671 billion parameters. Now, you're not going to want to run a model that is much larger than the amount of memory that you have on your computer. So I have an Apple M1 Max and I have 32 gigs of RAM. So this model, they give you the number of parameters here, and they also give you the size in gigabytes. So with 32 gigs of RAM, I don't really want to run a 43 gigabyte model. There's not enough RAM to load the model into the computer's memory, which means if it works at all, it's going to use the hard drive or solid state drive for swapping, and that's going to be really slow, hundreds or 1,000 times slower than RAM. So we're going to use the largest model that will fit in RAM, which is going to be this 32 billion parameter model. So you just pick that, and then it gives you the command over here that you need to run to download it. And this is DeepSeek R1, and this just means the 32 billion parameter variant. So let's copy that command, and let's go ahead and run it. Now this is going to take longer to download. It's almost 20 gigabytes in size. And while it's downloading, I'll tell you a little bit about why running these models locally on Apple Silicon is kind of cool. First of all, the size. 32 billion parameters, how can it only be 20 gigabytes, which is 20 billion bytes? It's because of the quantization. Q4 means that there are only 4 bits used for each of the weights. And that 4 bits is half of a byte. So 2 of the weights will fit into a single byte. So for 32 billion parameters, 2 of them fitting into a byte, it's going to be about 16 gigabytes plus some overhead. So that's why your model size over here is 20 gigabytes. It's closer to 16 than it is to 32. So just to explain a little bit about what those numbers mean and give you an idea of what you can do. So why is running this on Apple Silicon cool? You can run large language models on GPUs, NVIDIA graphics cards, and other accelerators. But the issue is most of these consumer graphics cards do not have enough memory on board to run these larger models. Your GPU has maybe 8 gigabytes or 16 gigabytes or 24 gigabytes if you're lucky. But the Apple Silicon CPUs have an architecture where the CPU cores and the GPU cores and also the neural processing unit, which is specifically made for AI acceleration, all of those are on a single chip. And they're all connected to the system memory directly. They all have full speed access to all of the RAM in your computer. So if you purchased a Mac with 32 gigabytes of RAM, that means that your GPU cores can access all 32 gigabytes of RAM. The neural processing unit can access all 32 gigabytes of RAM. And because there's only a single unified memory space for all these different components, there's no need to copy data back and forth. So in a PC with a dedicated graphics card, you're going to have your model loaded into the computer's memory and RAM, and then that's going to be copied over the PCI bus to the graphics card's memory. And then the calculations are going to happen on the graphics card, and then the results are going to be copied back from the graphics card's memory over the PCI bus back to your system memory. So not only are you limited by the memory on the graphics card, but you're also limited, or it's slowed down by the fact that this data has to be copied around from different types of memory to other memory in other places, which doesn't happen on the Apple Silicon unified memory architecture. Now, this isn't something Apple invented. AMD has been making processors for many years called APUs that have built-in graphics cores on chip. But those designs sort of predate the rise of AI that we see today, and they're not really optimized for it. So there are some new laptops coming out with AMD Strix Point APUs and other, I think they're going to be called Ryzen Max AI or Max Plus AI chips that are going to be more comparable to what the Apple Silicon architecture is currently able to do. But those are just barely coming out. I'm not even sure how many devices are for sale yet. And as far as I know, those chips are for thin and light notebooks, and they're not really for desktops. So right now, the Apple Silicon is kind of a neat platform to work with. The downside is you need to have a lot of RAM if you want to use these large models. And the Apple Silicon CPU does have a really high memory bandwidth, and that's only been improved with each generation, as well as the performance of the GPU cores and the neural processor. It's, 10-15% improvement each generation. So if you really want to run big models, you will have to be prepared to spend big money. You could get, for example, a Mac Studio with the M2 Ultra processor, which is the largest one Apple has made. And I believe that machine can be configured with up to 192 gigabytes of RAM. So, but that's not cheap. You can find them on eBay about $5,000 and up. So let's ask this model what it's good at. So this is DeepSeek R1, 32 billion parameters. Now, it's a larger model. It's going to be slower, and it takes some time. This tag right here, think, and the close think tag, this is where the text appears that explains the thinking process that's going on inside the model before it generates its final response. I guess there wasn't a lot of thinking for my simple prompt. But you can see the answer. I'm a general purpose AI created by DeepSeek. For comprehensive details about our models and products, we invite you to consult our official documentation. Now you can see some of the thinking process. And now that I've interacted with the model a bit, a lot of the parameters are in the CPU's caches, so there's less of a delay when it starts generating response. A lot of times I don't really like to read all of this thinking stuff just in a chat, but like I said earlier, if you're doing problem solving, it can be very useful to see how the model is reasoning about the problem that you've given it. So let's go ahead and ask it the same sort of question. Can you write me a small program in Python that creates a list of 10 random numbers, then using an explicit bubble sort algorithm sorts the numbers from least to greatest. Finally, display the original list followed by the sorted list so we can see that the sort was done correctly. It is kind of interesting to see how these reasoning models break down the problem that you've proposed, and you can see sort of what resources it gathers together mentally, so to speak, to approach the problem and to figure out a solution to it. That wasn't too bad. And even though this model is definitely slower than the Phi-4 model we used earlier, it's also a lot bigger and it can do the deep reasoning. So if you're using it for the right sort of task, you can definitely get more out of it. And even though it's slower, it's still displaying the output faster than I can read it. Okay. This looks like a shorter program. Let's just copy that. And let's paste it in here, text file, and let's run it. Well, there's our random numbers, and here's the sorted output: 1, 5, 32, 46, 49, 50, 68, 81, 87, 99. That looks good. So this is just a simple demonstration of running AI models locally on your own laptop or desktop using Apple Silicon chip. I'm going to turn off my Wi-Fi again, and we'll just, you see I'm off the internet. I'm going to close terminal completely, get that out of the way, go back in, and load that model back up. It's already been downloaded to my hard drive. It's there. And interacting with it is going to work just fine, even though I have no internet access whatsoever. Again, nothing I type into this chat is sent anywhere off my computer. It's not sent over the internet. It's not sent to any web service. It's not sent to any servers in the cloud or running in any other country. Just all my own computer. You don't have to use it through this little terminal chat. It has an API, so there's a local port that it opens up, and if you want to write another app that connects to that port, you can send JSON formatted commands to load up whatever models you have. You can have multiple instances running at one time, and you could create your own agents to do different things that way, all on your own computer. Or you could, open that port on your firewall on your computer and access it from other machines on your network and have a little AI server in your home or in your office. A few other things. If you want to see the models that you've downloaded, here they are, Ollama list. And if you want to remove one of them, you just take the ID, paste it in there. Okay, make a liar out of me. Not the ID. Just the name of it. And then that's going to delete it. Now I only have DeepSeek. So if I wanted to try running that one again, it's not going to work because I deleted it off my hard drive. I'd have to get back on the internet, right, and download it again. And then I can re-download it and use it offline after it's been downloaded. So I hope that was interesting and shows that it's possible to utilize this technology for free and to use it in a way that is private and secure right on your own computer. If you are a Mac user or into that ecosystem, it's good to know that the Apple Silicon chips do have some useful AI capability built in. And if you have the money to spend, if you want to continue working with this sort of thing, on your Mac, I would recommend definitely buy as much RAM as you can in the beginning, because these Apple Silicon CPUs, the RAM, the memory chips are actually part of the CPU package. They're not something you can upgrade. It's not memory sticks that you can just put into a slot. So whatever RAM you purchase the computer with, that's what you're going to be stuck with until you replace the computer at some point in the future. So I would recommend for AI 32 gigabytes as a minimum. When I bought this laptop, I've had it for a number of years. AI wasn't really on my radar, but fortunately 32 gigabytes is usable. But if I were to go buy another one today, 64 gigs would probably be my minimum. And if you want to go big, you go with something like a Mac Studio, and you can go with 128 gigs or maybe 192. They haven't released a Mac Studio with a, since the M2 Ultra, which is, like I said, the largest of the Apple Silicon chips. Not necessarily the fastest in every way, because there's the M3 and M4, but it's the largest in terms of number of cores and how much RAM it can be configured with. So hopefully they'll be coming out with a new Mac Studio, maybe an M4 Ultra or maybe an M5 Ultra, something like that. And if we're lucky, maybe they can be configured with 256 gigabytes of RAM, which is kind of like, server territory. But that would be really useful for AI models. You could run models that were, 500 billion parameters. GPT-4, I believe, is somewhere around there, maybe 600 or 700 billion. So it's pretty amazing to think about running something as large as that. A company that has invested, hundreds of millions or billions of dollars in data centers and equipment to run these models. Of course, they're running them for many, many, many users simultaneously, but you can run models of a similar power and capability right on your own computer for free if you have invested in the amount of RAM that you need up front. So if you have any questions or would like to know more about this topic or things that are related, just leave those down in the comments.